3. (1.02 times 10 to the 29 free electrons per meters cubed). We know this equation is going to be related to the I equals nAvq. That's how I like to remember it. I equals nAvq. Okay, so straight away we know that because it was mentioned in the unit, and also here they're saying copper has a number of free electrons, so we know that N equals 1.0 times 10 to the 29 electrons per meters cubed. A is the area, and so forth. Let's see what else it tells us in the question. Calculate the mean drift velocity. So we want to know V. And the cross-sectional area is 5 times 10 to the minus 6 times 10 to the minus 6 meters cubed, squared. And the current is 13 amps. I equals 13 amps. And we know that Q is the charge of an electron, which is 1.6 times 10 to the minus 19 coulombs. So here we want to know V, so we just rearrange for V. V equals I over nAq, big A. And we can sub in the numbers. V, I is 13 amps, divided by, and then just put in the numbers here. N, we've written down 1.0. We're going to put this in brackets. 1.0 times 10 to the 29 times A, 5.0 times 10 to the minus 6 times Q, 1.6 times 10 to the minus 19. Lots of numbers, but don't let that scare you. Just a normal calculation. We could have put the units in, we did on the top, but it doesn't matter when there's a lot of numbers like that. Okay, so here, let's just plug in the numbers. 13 divided by, open bracket. We've got to put the bracket in there because otherwise it's just going to do 13 divided by the first one and then multiplied by. We don't want that. So we don't need to type 1 there, we just put 10 to the 29. 10, where's shift? Tilted the calculator, let's shift. 10, wait, that's not what we want. Don't want shift, we want 10 to the 29, there we go, move it across. Times by 5, we don't need to put in the 0.0, times 10, and then minus 6, and then times 1.6 times 10, and then again minus 19, and close brackets, and that should in theory give us our answer. Again, in physics we always can't leave it in fraction form, so we'll change it to decimals. 1.625 times 10 to the minus 4, and that is meters per second. And don't forget, we need to pay attention to, you know, the decimal places here. This is or the significant figures, 2 significant figures, 2 significant figures, 2 significant figures. We want our answer as 2 significant figures. 1.6 times 10 to the minus 4, 2 significant figures. Wait, I missed out meters per second. 2 significant figures. Okay, and there we go.